I don't remember where I was. So the sign at 225, that's going to be negative root 2 over 2. And the sign at 150 is going to be 1/2. Okay? So then this becomes the square root of 6 over 4 plus negative square root of 2 over 4. And when I combine those, I end up getting the exact same thing. Okay? So again, it doesn't matter which two angles you choose to use. Okay? Alright? So, when we're in radians, then we gotta kind of think, alright, what two, I gotta now try this as a difference. Oh yeah, okay, alright. So we gotta kind of think what two angles add up to be 5/12ths, or what two fractions add up to be 5/12ths. Two fractions that add up just to be 5/12ths. We'll get to the unit circle in a minute. 5/12ths. I could go 1/12 and 4/12ths, or I could go 2/12ths and 3/12ths. Okay? 1/12, if I bring the pi into it, that would be like pi over 12. That's not on my unit circle, so I'm not going to use that one. But if we went the sine of 3 pi over 12 plus 2 pi over 12, that's going to be, when I reduce those fractions, that's going to be the sine of pi over 4 plus pi over 6. And now both of those are on my unit circle. Right? Okay? So then this is number 19 now. That would be the sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4, the sine of pi over 6. According to identity number 19. Sine, cosine, cosine, sine. Sine at pi over 4 is the square root 2 over 2. Cosine at pi over 6 is the square root 3 over 2. Plus cosine at pi over 4 is root 2 over 2. Sine at pi over 6 is 1/2. So I get the sine of 5 pi over 12 is equal to the square root of 6 plus the square root of 2 divided by 4. Yes, sir.
So before, when we were doing the cosine, and
Yep.
adding both the different degrees.
Yep.
If we were adding it, we had to then subtract it.
Because the cosine formula is different than the sine formula,
Okay, so
or the identities, I should say.
But, yeah, for this one, if we're adding both.
If this one, the sign stays the same. So the SIG end stays the same. The operation stays the same. On cosine, it flips.
So if like the sine was like negative,
So if we did it as a difference,
like
let's say we
6.
did it as a difference, okay? Could I do 6 pi or 6 pi over 12 minus pi over 12? Because pi over 12 is not on there, right? So we'd have to do something a little different. Okay, so let's think of a difference here now for this one. 5 pi over 12 in difference formula. So you're saying the sine of 8 pi over 12 minus 3 pi over 12? Okay, because then that would be the sine of 2 pi over 3 and pi over 4. That works for me because both of those are on there, right?
Yeah.
Right, both are on the unit circle. In the end, we should get square root 6 plus square root 2 over 4. So then this is going to be the sine. Oops, I know for sure I'm going to have to move this over. The sine of 2 pi over 3 cosine of pi over 4. Because it's a subtraction now, that becomes a subtraction. Cosine of 2 pi over 3 sine of pi over 4. Cosine at 2 pi over 3 is negative 1/2. Cosine at pi over 4. Oh, I did cosine at 2 pi over 3, not sine of 2 pi over 3. That's the square root 3 over 2, square root 2 over 2, minus cosine now is negative 1/2, and square root 2 over 2. So then this becomes the square root of 6 over 4 minus negative square root 2 over 4, which ends up becoming that one right there. Okay? Good? Let's try a tangent one. Okay? So I need two fractions that add or subtract to be 11 pi over 12. What you got? 8 pi and 3 pi? 8 pi over 12, and I'm guessing you're going plus? Yes? Okay. Could have we done 14 pi over 12 minus 3 pi over 12? Yeah, because 14 pi over 12 is 7 pi over 6, right? Okay. Yep, we could have done that one. Right? So tangent is formula number 21. So that's going to be the tangent of, well, let me bring this down a little bit. Maybe. There we go. So this is going to be the tangent of 2 pi over 3 plus pi over 4. So that's going to be the tangent of 2 pi over 3 plus the tangent of pi over 4, all divided by 1 minus tangent of 2 pi over 3 times the tangent of pi over 4. Okay? I know what the tangent at pi over 4 is. What's the tangent at 2 pi over 3? Negative square root 3. Okay? So this is going to become negative square root of 3 plus 1 all over 1 minus negative square root of 3 times 1. If I make the top look nice and pretty, I get 1 minus the square root of 3. If I make the bottom look nice and pretty, I get 1 plus the square root of 3. Can I simplify that fraction? We can. Yep.
Wait, why can he go?
We always have been able to.
I thought we could not have it.
We can. So what you're saying, you want to make it look even prettier?
Well, I don't really care, I guess.
Well, I mean, you got to tell me.
Well, that's
If
good.
you rationalize your denominator, I'm fine with that too.
Okay.
Yeah. That's good. Okay. Working backwards now, you just kind of look and see which one's which. So cosine and cosine together, is that cosine, sine, or tangent?
Cosine.
It's cosine, right? Okay. So this is going to end up being the cosine of 42 degrees and 12 degrees, right? Are we going to add them or are we going to subtract them? We're going to subtract them. So this ends up being here the cosine of 30 degrees, or if we wanted to, because that's on my unit circle, we could write that as the square root of 3 over 2, because we know that exact value. If it were the cosine of 54 degrees, then we would just leave it as the cosine of 54 degrees. Okay. Cosine sine. Sine cosine. That's a sine. So it's going to be the sine of 7y and 3y. And what am I going to do with 7y and 3y? I'm going to add them because sine says it's the same SIGN. So then this one is just the sine of 10y. That's it. Tangent minus tangent over 1 plus tangent tangent. It's tangent. Am I going to add or subtract 3b and 2b? Subtract? Subtract, yep. So then this one is just the tangent of b. Okay? Good times. Now, what I'm going to hand out for you right now is the section 5.4 note page. Okay? So what I would like you to do is, I would like you to start this. Your homework for this evening is to get the first 2 pages done. Okay? The first page is proving the double angle formulas based off of what we just learned. The second page is then utilizing that, putting that into application mode. I do have one thing to explain on the front side, and so I'd like to explain that right now. I didn't do a very good job of editing. So over here, this is number blank on your unit circle. You don't have unit circles, okay? So you're going to cross out unit circles. and you're going to say this on your properties or identity. Actually, identities is better. On your identity sheet. On all of those. Okay? So these are the double angle formulas which are on your identity sheet. Okay?